Thank you for joining us for today's Caringo Tech Tuesday webinar. This session's topic is moving data from SAN, NAS, and tape to object storage. I'm John Bell, Senior Consultant at Caringo. Today I have as our guest Caringo's Director of Product Management, Eric Dey. Eric and I will be available to answer your questions throughout the webinar and at the end of today's presentation. In addition, we have a couple of resources available via the Attachments and Links window on your view screen. If you have questions after the webinar, you can always reach us by emailing info@caringo.com. And just a quick introduction, again, this is John Bell. I've been with Caringo for 7 years and am a senior consultant on the design, implementation, and management of object storage. I've worked with many of our largest customers to transform their storage infrastructure with highly efficient and cost-effective object storage solutions. Eric, please introduce yourself.
Thanks, John. I'm Eric Dey. I'm in charge of the product management at Caringo, and I have been with Caringo since the beginning when we had to convince people that HTTP could actually be used for storage. Now, object storage is mainstream, and it's used for a broad spectrum of applications. My background is in information technology, and I've been involved in the design and the implementation of all aspects of Caringo's storage solution.
Thanks very much, Eric. And just to add some more color to that, Eric is one of the originals here at Caringo and has been with us from the very beginning and definitely knows the ins and outs of object storage technology and solutions. So just some quick introduction of Caringo as a company before we begin. Caringo was founded in 2005 to change the economics of storage by designing software from the ground up to solve issues associated with relentless data growth. Caringo's flagship product, Swarm, decouples data from applications and hardware, providing a foundation for continued data access and analysis that constantly evolves while guaranteeing data integrity. Today, Caringo's software-defined object storage solutions are used to preserve and provide access to rapidly scaling data sets across many industries by organizations such as NEP, IQ Media, Argonne National Labs, Texas Tech University, U.S. Department of Defense, the Brazilian Federal Court System, City of Austin, Texas, British Telecom, and hundreds more worldwide. So just a quick rundown of our agenda for today. We will go over the standard storage architectures that one typically encounters in the field. And we will compare those current storage technologies that are associated with those architectures and basically formulate some plans and use cases around how to do migration from those storage technologies to object storage. We'll discuss 4 of the primary data transfer methods that are involved in that work and some additional considerations that are associated with data migration in general. And then finally, we'll follow up with addressing any questions you have during the course of the presentation. So typical storage architectures that you encounter today basically fall into 3 categories. They're going to be reading right from left. They would be block storage. That's accessed by client applications by OS calls and typically involve fixed system attributes, are used to handle transactional data, and are primarily targeted for applications that place a premium on performance. Moving to file, we also have client access by operating system calls. Also fixed file system attributes are involved in file-based protocol access. Typically, that's used for shared access to changing file with multiple mounted clients mounting the network file system. And that can provide access basically at a single site. You typically don't see file-based storage as cloud-enabled. And then finally, we have object storage. The client is the application itself, and that application is not making so much system calls as it is making RESTful API calls, and we'll go into that in more detail as we go through the presentation. Object storage, the objects themselves are tracked typically not by their name or by something by UUID, but are also accessed or referenced by their characteristics or their metadata. And that metadata could be, fixed metadata that's supported by the application out of the box, up to and including custom metadata that's associated with it when objects are instantiated in storage. Typically, that's going to be a shared semi-static object of some kind being accessed by multiple applications. And object storage in general is designed to be a scale-up, scale-out architecture for the handling of unstructured data, and would be cloud-enabled, accessed by multiple sites, sometimes even simultaneously. Eric, did you have anything to touch on this?
I do. So what we have here is really a reverse evolution of storage. I will start at the right and going to the left, like you did here. But what we have is block, which was kind of the local storage attached to a local computer. And as we move to the left, what you're doing there is you're getting more clients distributed clients trying to talk to the same set of content within your system. And so you go from block, where you've got pretty much private one-to-one access to stuff, to going to file, where you have more of the file share. So you have multiple clients still talking to one storage target at that point. And then you go to object, where you've distributed out everything. So your clients are distributed as well as your storage is distributed. You're no longer talking about one disk drive or one NAS array in the system. You're really got a cloud for storage and multiple clients all interacting with that same content. So it's going from localized access to very distributed access and very distributed storage as you move from block to file to object.
Great, thanks. Would you think it's fair to say that the block and file categories tend to lend themselves to siloed storage, where you have some things in a block storage or a SAN over here, and then you have some other things in a file storage over here, and you can get yourself into a situation where you constantly need to move data, back and forth between them all the time?
Yeah, that actually is a characteristic as you're more towards the right side of this image here. So block is very constrained to, what was one disk drive originally is now, a SAN. But really, once it doesn't have a way to talk to lots of clients that are attached to block don't have a way to talk to lots of different block targets all at the same time in the typical architecture, because the attachments were, not originally, but a couple decades ago, SCSI cables, and now you're talking about fiber channel or iSCSI, but still it's predicated on this idea of kind of private access to the storage. And so it does create a silo in that once there's no real way to share that with other applications very easily. File gets a little bit better in that now you can start to share files with other clients in the system, but you still do create a silo in that the NAS itself is it's a finite quantity. It fills up, and then at that point, what do you do with it? It's also not predicated along the ideas of having thousands of clients talking to a NAS or tens of thousands talking to it. So it's a little better, and it's not quite as siloed as block, but it still definitely is a silo there. And then object kind of explodes all of those limitations, that it is predicated along the ideas of tens of thousands of clients talking to who knows how many actual distinct storage entities within the object storage cloud.
Mm-hmm. So basically, you're trying to migrate away from what I've heard called the tyranny of the file system, right? It's not something that's easily accessed or manipulated by like you say, a very large group of clients all at once, and scaling beyond file system limitations can be difficult.
That's right. One of the things object storage gives you is, I'll describe every IT administrator's challenge and and nightmare, which is what happens when you fill your NAS or your SAN. You have to orchestrate some kind of upgrade. And that typically involves figuring out everybody who, over the years, happened to be talking to a particular file share, and figuring out how you are going to, with as minimal downtime as possible, how are you going to move them to a newer unit that has more capability, more storage space. And that gets, with block, that's a very intimate thing, because you're talking about usually something like a database that's using the system. It's difficult to kind of copy stuff ahead of time to it. You of course can with snapshots and differential copies. It gets a little easier with file, that you can kind of do a bulk copy of files and then come through and catch the ones that have changed that you did your copy. But then really that whole sort of exercise goes away once you get to object, and that it's predicated along the ideas that content's going to live a lot longer than the hardware on which it's stored at any one time. So the hardware is designed to be replaceable in the system, and it's designed to be replaceable with no visible change to the tens of thousands or millions of clients that are using it.
And ideally, no downtime.
And no downtime. That's right. That's they don't realize that you've switched out the hardware behind them, because hardware, retiring hardware and replacing it, so hardware refresh, should be a designed, architected part of the storage system. Because if it's not, then what it does is it creates resistance to want to do the upgrade in the first place, because it is so difficult, and then a lot of extra work and energy and downtime as you do the migration.
Very good. Well, I think that's a pretty comprehensive look at the storage architectures and some of the challenges that architects and operators face when they're designing and working around them. Let's move on to the next slide, because we have a pretty good chart here, where you compare current storage tech along the lines that Eric and I have just discussed. The architecture choice cross-referenced with the technology such as SAN, NAS, object storage, or tape. And I'm not going to read all of these off to you, piece by piece. They're pretty easy to figure out. But I would ask that you put a focus on the object storage column, because what you'll find is if you look at the characteristics associated with the object storage column, you're seeing what a lot of people in the industry are starting to realize, especially customers that Eric and I work with, is that there is a convergence on this object storage idea of a cloud-enabled access to a storage target, where you can scale up and scale out not only the storage itself, but also the client load that it can take, and the performance is good enough, right? You don't have to spend a large amount of money to get that, to eke out that last 20% of performance, like the 80-20 rule. And especially in a world of unstructured data, which is the vast majority of data that you're managing in your organization, object storage is the ideal way to store and manage it. It scales up to exabytes in size. Performance depending on what type of resources you bring to bear to it, such as networking for clustering, the type of disk technologies you pick, and so on, can range from very tight milliseconds to maybe a little bit slower depending on what's being done. A very big change there in accessibility is the accessing it by an API call, a RESTful API call, HTTP calls like Eric alluded to earlier, and we'll go into that in a little more detail later. Looking for the needle in the haystack with search, being able to find, in this large data lake of things that you have stored, exact files or objects, pieces of data that you're looking for, and the ability to do those queries, and ideally to be able to store those queries as live queries, things that you're going to be looking at all the time. It's something that we call a collection, meaning that anytime you reference that collection, any object that meets those characteristics in the defined query is going to be presented to you, and that's going to be constantly updated as new data comes into the system that has those attributes. It's very easy to enable cloud-enabled object storage, like we said earlier, with RESTful calls based on HTTP protocol. You're speaking the language of the web, so cloud enablement is basically built into that type of solution. And then finally, you have durability, where you have multiple protection schemes to choose from, be that EC in this case, which is erasure coding, whether it be protecting your data with multiple copies of it within the storage cluster. And then associated with that, being able to set the policies for how data will be protected at different levels of context within the cluster, such as protection policies for domains or buckets, or even down to the individual objects themselves. Eric, did you have anything to add to this?
Sure, I do. Object storage, it says on this slide, moderate performance in milliseconds to seconds, but I wouldn't necessarily call object storage slow any longer. It's as you said, John, it actually is an appropriate speed for most applications that are trying to get at their data, especially when you think about billions of distinct pieces of data and tens of thousands of clients that are all looking at similar stuff. We talked about, in the storage industry, we talk about performance in terms of how fast does my wire go, how fast is that SCSI cable, how fast is that fiber channel or InfiniBand or something like that. And the reason we're talking about it like that is because what we're trying to do is cram every single request that's going to any content on those SANs or NASs down into this one pipe. I'm oversimplifying a little bit there, but when you get into object storage, what you're looking at now is a fully switched fabric, where you've got hundreds or thousands of distinct storage components within the object storage cloud, as well as then you've got all of your clients out in front, and they have individualized channels to the content that they're using. So you're no longer trying to stuff everything down into one fat pipe with low latency. You've actually now got very expansive, switched Ethernet style environments, 10 gigabit. It's kind of the norm right now, and we're going beyond that as we go forward.
Very good.
I also wanted, yeah.
We have a couple of questions from the audience. Let's tackle those while we have them. The first one we have is, how does the EC or erasure coding differ from RAID? Did you want to tackle that one?
I sure would like to tackle that one. So I'm going to very simplistically say it's the same thing, in that you take the data, the data that you're storing, and you slice it up into data segments, and then you apply some parity segments to it as your protection. Now, it's different in that with object storage, you are doing that erasure coding on a per object basis. You're not doing it on a volume, a volume basis that your SAN or your NAS may have a few storage volumes, and you decide ahead of time that everything that goes on that logical volume is going to be RAID 5 or RAID 6. Instead, with object storage, what you're doing is you're deciding on a per content basis what the erasure coding is for those objects, and they don't have to be the same. And so what that gives you the flexibility to do is that you can have some content that is thinly protected, not as much overhead to data protection and parity, and then your more important content could be protected with a lot more durability. In other words, you could say, I want 3, 4, 5 parity segments with this particular data. So it gives you the flexibility to choose very granularly how protected you want individual pieces of content, So it's similar to RAID in that it's this slicing up of the data and then applying some number of parity segments that are equal size to it. But it's different in that you're making it decision granularly, and you can change it over time with object storage. Whereas RAID is very fixed and it's a one-time decision, and it's very it's all encompassing of everything that's going into that bucket, that volume.
Mm-hmm. I'd add to that, the other way that it differs is in its behavior. So in the case of an erasure coding implementation in an object storage cluster, let's say, for the sake of discussion, that a volume or a couple of volumes in the cluster dies, right? In the case of a RAID array, you have a RAID controller that's being faced with the prospect of, having to rebuild the entire array. And that could take some time. And that can be bottlenecked on the performance of the RAID controller itself. With erasure coding in an object store cluster, these recovery scenarios are, for one, highly parallelized because the entire cluster participates in the rebuild of the data. And they're very fast because it's only rebuilding the data that was affected by the failure. So it's only rebuilding the objects that were affected by those one or two volumes or even an entire server going out. So you're not constrained by the performance of your RAID controller. And again, that goes back to the concept of, siloing these operations and instead exploding them out and allowing the whole cluster to participate in rebuild and reconstituting the objects that were affected by the outage. And operationally, it's a huge difference being able to tackle recovery that way versus traditional RAID systems.
Yeah, so if you've got 10,000 disk drives in your object storage system, in other words, you're having you lose one of the drives, so you're having 9,999 other drives all participate in the recovery of that, and so their shared load is a very, very small fraction of the aggregate recovery that is going on, whereas with traditional RAID, you have a very high impact that occurs on the remaining drives in that stripe or in that volume that you're doing the recovery for.
Mm-hmm. Okay, hopefully that tackles the questions around RAID. I'll go ahead and mark that as answered. The next question we have, Eric, is what sorts of data are not appropriate to store on object storage?
So, object storage is about storing a piece of content and maintaining its representation in a consistent manner. So, think of it more transactional in that when I write something into the storage system, I now have a full and complete copy of it in the system. And if I'm going to update that object, that file, that piece of content, I'm going to supply a new full copy to the system so that it now has the new revision of that object. And we get into things like versioning too, where you could preserve historical versions of an object in the system. But it's not suited well for things that want to do incremental changes. So really, it's not a good store for your relational database.
Mm-hmm.
It's not going to be the backing store for that because that is pretty much 100% all incremental block changes. Changes to little bitty pieces of the internal representation, and a database doesn't really. A database may have a multi-gigabyte file, but it's not really a file. It's actually its own internal structure, and so the thing doesn't really represent. The storage from a relational database doesn't represent anything to anyone else external to the database application. Whereas object storage, the pieces of content, the objects in the system are whole, and that if I put an image in through one application, another application can recognize that image and can display it and do other things with it.
Mm-hmm.
So it's typically not appropriate to use object storage for stuff that requires incremental updates. Now we do have some patented technology that does allow us to make incremental updates to objects. But in general, that's not going to perform at the same level that applications like a relational database is going to expect their storage system to respond at. So there still is there's a very big place in the world for block storage as it relates to the back end for relational database systems.
Right. And I think what we found in working in the field is that the combination of being able to say, have your block storage for that specific use case, but being able to do things like take database dumps and then move those dumps off into something like an object store target, and being able to know that that's a well protected database dump with erasure coding, and have it be near line on something in case you needed to recover that database for whatever reason, as opposed to being able to have to go to tape for it, is a huge advantage as well. Yeah. Okay. And we have another question that came in. What criteria can someone use to specify the amount of parity for certain segment of objects by certain metadata values? So, yeah, go ahead.
I was going to say, so that is done on a few different ways. You've got global settings for your storage cluster. You have settings on each of the logical organizational structures within the system. Within our system, we have tenants and domains and buckets, and then you can also set it on a per object basis. And so you've got it as granular as you want, or you can kind of move up the tree and start to group things together to control how much parity or whole replication. There are definitely cases where whole object replication is more appropriate than doing erasure coding. And so we give you the flexibility to choose how much durability you need at multiple levels within our system.
Mm-hmm. And from a planning perspective, I've found that this question typically comes up when people are trying to decide, say they may not really know ahead of time the characteristics of their data, such as what type of data it is, how big the files are, in general, on average, things of that nature. And they have a difficult time figuring out what those initial global settings should be. Like, say, for erasure coding, what should my global erasure coding scheme be? Or what should my global replication scheme be, depending on certain things. And what we usually, when we're sizing an object storage solution, there's two things that I like to look out for. I want to know how many files or objects you plan to store in the system. And if you can get an idea for it, on average, how large those files or objects are going to be. The answer to those two questions right away are going to give me a very strong idea of what type of strategy should be used for data durability and object protection in your solution, because it's going to drive areas related to storage footprint that's going to have an impact on your storage license capacity, for example. All of those things come into play, but those two main inputs, object count and average size of object, are really what you want to look at when you're planning around the protection schemes you're going to use, what type of efficiency you want to get out of the system, what type of licensing budget you need to have, and so on. The metadata values don't play as large of a part there, because typically the metadata that's associated with the object is very small, from a capacity footprint perspective versus the body of the object itself. So to a certain extent, metadata needs to be accounted for, but it's not as large of a driver as the overall size of the objects themselves.
I'd also say that the question, I'm going to read into the question a little bit here, and that there's actually the painful questions that storage administrators always start off with in the initial deployment, and that is, how much protection should I use for everything that is ever going to be stored here? And that is a question that doesn't really apply in object storage. But the reason that people start with that question is because it's really, with SAN and NAS, it was a global, immutable, and long-lived decision that you had to make when you deployed the system, and you could never change your mind, at least not without picking everything up, reformatting it, and dropping it back down. And that's just not the case in object storage. You're actually free to change your mind over time. You may decide that, you know what, I maybe chose too much protection to start with, and I want to lower the default down and let the system itself go through and convert everything over time to the lower protection level, unless there's some more granular policy that says that particular content really does need a different kind of protection.
Mm-hmm. Yeah, that's a huge difference, is being able to change that type of approach on the fly in object storage versus the other technologies.
Right.
All right. Well, let's move on. We got to keep with our time, so we'll go on to the next slide. Okay. And here we have your typical use case mapping diagram for, which technologies are typically chosen depending on the use case that's in play. And as you can see, as you would expect, for SAN, those are typically used in high transaction, RDBMS type of environments, or perhaps, tier 1 storage, collaborative storage, things of that nature. That's very local to one location or one file system. And similarly so for NAS. Whereas object storage, the use cases where it starts to shine are in what we would call distribution and delivery, or what I like to call publication, for lack of a better way to describe it, where you've put that object in the system and you're basically handing a group of people that could be of any size, typically a very large size, what amounts to a URI target to go get it and work on it. In similar vein, object storage shines for tier 2 and active archive, where you have a large group of people wanting to access things and access it quickly. Or it could even be used for cold archive. We have customers in the field where they need what amounts to a worm target. And you're able to do that with an object storage solution. And the way you do that is by specifying on the object that you don't want the system to allow deletes on the object. And what you have there is an effective worm as a result, and an effective cold archive. That as time goes on, that object won't have been deleted. As Eric alluded to earlier, that as the technology changes out from underneath the objects themselves, different servers, different networking technologies, and so on, that object integrity is maintained, right? We have a concept of what we call volume portability or object portability within swarm object storage, and that's what we're talking about, the capability to know that that data will survive over 5, 10, 20, 30 years of changes in server and networking technology, and still be accessible by the attributes that define it. Any color to add here, Eric?
Sure. I was going to say that really tier 1 and tier 2 are not rigid definitions.
Right.
That tier 1 is often meant extremely low and absolutely consistent latency. Really think about relational databases. They need to know how fast they can get a block out of the system, and they need that amount. They need that number to stay highly consistent. They need to be extremely low, sub millisecond. But there are plenty of applications that, especially modern applications that are designed from the start to use object storage, that are using object storage as their only storage system. So this is not meant to say that you should store first somewhere else and then move it into object storage. This is really more of a comparison of typical breakdowns of what people call tier 1 and tier 2. But there are plenty of modern applications that just skip the disk altogether and go straight into object.
Right. And actually that leads into our first question. I'm going to tackle this one, Eric, because it's a good one. And the question is, we would like to replace a tape library with a replicated Caringo solution. What is the best way to go about it? And the key there is replicated. And we run into this use case a lot where people have traditional tape libraries, and for business continuity planning and so on, they have requirements that what's in that tape library also needs to be replicated to some other physical location. And that's where managing these complex tape libraries becomes really difficult and really expensive. And object storage is a great solution for addressing that type of use case. And what we usually end up designing in the field for people that have those requirements, some of you working with backup solutions in the audience have come to realize that a lot of the backup solutions like Commvault and so on are starting to come to market with object storage targets, like being able to back up to S3, for example, or being able to back up to an S3-like local object storage implementation, such as Swarm storage. And when you do that, that really opens up a ease of putting together what's needed to meet this requirement, because you can set up, say, a Commvault solution to point to an S3 protocol personality that Swarm is serving up. And what will happen is that Commvault data will end up in the object store. And with our wide area replication feed technique, we call replication feeds, you can set things up so that anything that's written into that local object store will automatically be replicated over to a target object store that's, say, in a different physical location, be it across town, be it across the state, be it across the country, or across the world. It all depends on what your requirements are. And again, you're just using standard HTTP protocol to do that. So what you get is you get a near real-time, eventually consistent way of being able to take whatever is backed up locally and automatically have it moved over to your DR site in case something happens. That would be a typical plan that we implement in the field, kind of a best practice how we would go about it. So you're looking for backup solutions that have the capability to back up to those RESTful based stores like S3 or even native SCSP like we offer. And then the clusters themselves can be set up to talk to each other, as it were, so that the data is automatically replicated. You don't have to worry about, doing that. It's just automatically done. Anything to add to that, Eric? Okay, very good. I'll go ahead and mark that as answered.
I'm sorry, I was on mute. I said something brilliant, but it was muted, so you won't hear it. John, I would like to add a couple things to it. I was going to say that traditional backup solutions that you think about, they do the following. They read your files. They encode your files as some kind of opaque storage container. And then they write that opaque piece of storage to some kind of back-end system. So they write it to a tape. They write it to a NAS. They even write it to cloud now. So they write it to object storage. But they write it as an opaque container. So it's not really useful to anything except that backup program. What's now in object storage. But there are actually some newer backup tools that are object first and object only. And what they do is they read your files and they write each file as a distinct object inside of the cloud or inside the object storage system. So they're accomplishing the same thing, but the benefit is that now other applications are able to reuse those, quote, backup files in a different way. So your backup system has written into object storage, but it's written each file, each thing you know the content as its own distinct object. And now you could reuse that cloud storage in other ways that you could have other applications that are actually making use of that storage rather than just making it a silo that your backup system only understands.
Mm-hmm. I'd say there's some service enablement to that as well, because typically what happens, somebody accidentally deletes something. and they open up a ticket with their IT department. The IT department has to load up the tapes that may have, what it is they deleted, depending on, whatever backup, scheme they have in place. And it runs through the tapes, and hopefully it finds what they're looking for. And then they have to surface it up to, the layer where the customer can actually see it again. It's a long, drawn-out process. It's painful. If you're doing the next-gen backup like you just described, where it is writing it as an actual individual object for everything that it's backing up, it's very easy to give an end user a content portal to go to and say, here's what you need right here. You can grab it from here. Or you could even give them a URI that says, open up this URI and it'll download it and it will cover it right to your desktop. So a very different experience, and the turnaround time on it is extremely quick, versus the more traditional, recovery techniques that are typically used.
That's right.
Yeah. Very good questions. Okay. Well, in the interest of time, let's keep pushing forward. So Eric, can you talk a little bit about these 4 methods of data transfer to object that we typically encounter in the field?
I think we've addressed a lot of this so far.
Well, let's just tick through them real quick.
Sure.
I'll just tick through them real quick for sake of brevity. Naturally, the 4 methods are: you could do a direct integration with the object store, and meaning that you would write something like a customized tool that would, load things from a client and put it directly into an object store. There are the data manager methods, where you have some third-party tools that are commercially available that would allow you to do that. There's manual migration. And then last but not least, you can engage the help of a professional services group to move things from your more traditional NAS or SAN storage to object. And let's dive into these in more detail. So with direct integration, that alludes to, again, what we were talking about earlier, the RESTful API, and the verbs that go with that, which, for HTTP are very simple. Put or post, depending on whether the data is new or needs to be changed. Get to get it. Performing head to get information on its metadata or info, the equivalence of those. And then last but not least, delete to, the full life cycle of CRUD operations for an object storage system. Direct integration is typically ideal for proprietary or homegrown applications. And they usually extract the maximum performance and functionality of the object solution because it's designed specifically for the type of data migration or data move that you're wanting to do. Now, naturally, since it is an in-house tool, there are going to be some ongoing development resources that you would have to dedicate to that to take this approach. Typically, what we find in the field is that people like to take advantage of S3 tools. It being kind of a de facto standard for object storage target, but the implementations can vary. It's kind of half and half for us. Some people choose to go with a native integration using our API. Some people choose to go with S3. It kind of depends on their use case and how many of the components of the solution for Swarm that they want to set up.
That's right. So direct integration is really, I misunderstood your question a few minutes ago. Direct integration is really about applications that are designed from the start to use object storage. And this is where I was saying that really the definition of what Tier 1 and Tier 2 means really is kind of, there is no real rigid definition for those. Modern applications that are designed from the start to use object storage are this direct integration. They don't store anywhere else first. As John mentioned, S3 is I just like to say S3 is the de facto choice by people because, in terms of a standard, it's whatever's published today on Amazon's AWS's website. That is the standard as of today, and it could change tomorrow. And so it is definitely an evolving standard. It has a lot of stability to it, but it does evolve from time to time. We've seen, like the V2 to V4 authentication signatures. We've seen some other alterations like around listing operation, that kind of stuff. But it's what people know, and there's actually a real good wealth of tools written to make use of it. We've also got, John mentioned, we support S3, but we also support our own native HTTP protocol, which gives some additional capabilities that are not available through S3. So really, our protocol and S3 have grown up in it's kind of in parallel over the last decade. They have a lot of similarities, but there are things that one protocol can do that the other can't, and vice versa. So there's the appropriate uses for both.
Right, and for direct integration, approaches, that's the type of decision you have to make. When you're building that in-house tool, which way you're going to go.
But okay, no matter which decision you make, you can actually, the content is usable through any protocol that goes into the
right.
So it's not a
the namespace is the same. Yeah.
Mm-hmm.
Very good. Okay. Then, of course, the next approach in more detail we have is the data manager approach. Archive, backup, asset managers, gateways, things of that nature. Taking this approach is ideal where you have multi-application access in your environment. You have third-party tools that basically act as brokers between the different storage technologies. Right? They're usually easy to deploy because they're commercial. They support multiple protocols and operating systems. Well-designed ones are going to be sure that the same namespace is used, no matter which storage technology it's interfacing with. Very important. We've touched on that in previous webinars, but I'll say it again. When you're looking for solutions like this, you want to make sure that they all reference the same namespace. You want to be able to feed data in from, say, client or asset manager X, and then be able to come in using client or asset manager Y and see it have the same the same name, the same context, the domain and bucket characteristics, and so on. You don't want to have these siloed namespaces that have to be translated between all the time, because that way lies madness. It's very hard to keep track of when namespaces are localized and individualized. You want them all referencing the same namespace. And that
That's
leads
right,
to
and I'll add
Go ahead.
Mm-hmm. I was going to add some flavor to that. An example that we see is that we have an NFS protocol conversion that lets you write NFS. Your NFS clients read and write into our object storage system, and on the back end, it actually creates whole objects. So if I had a JPEG that I wrote through NFS, it'd be a JPEG inside of the storage system, and I can pull it out through a web browser or something else. But we see the same mistake repeated over and over again with other file gateway implementations, where they will take some protocol on the front end, such as NFS or SMB CIFS, and they will create some sliced up representation of that file inside the object storage system that is unusable to anyone else, right, or undecipherable to anyone else. And so that's not very helpful in that you've siloed that content for that protocol and that particular file gateway that did the storage. So you haven't really opened up that content within the cloud. The cloud's not getting to add much value because the application that brokered it didn't add any value for you.
All right, and just to put a fine point on it, those type of behaviors are completely counter, to the whole goal of this presentation. The goal is moving away from SAN, NAS, etc., consolidating things into object. But when you're consolidating, as Eric says, you have to be very mindful of all these different protocols that clients are using to access that data, and you want them to be able to access things and see things all in the same way. And that's what the unified namespace brings to the table. Okay. So the third methods we have are manual migration, and these are typically, using what I would say are more batch-oriented tools, such as rsync, rclone, cron jobs that do those type of operations periodically, manual copy and delete, and so on. These type of migration methods are usually used when you're decommissioning old infrastructure and applications, and you have some new stuff that's more object aware, and you're going to be referencing it through the object store from there on out. These utilities are usually free, hence the low cost, and some things you need to take into consideration are validation upon migration, making sure that the data, once it's migrated into the object store, maintained its integrity during that operation, and any associated error correction that might be involved with those operations.
I would say also, though, John, that if you've got an existing NAS or file share that you need for your enterprise, tools such as rsync, rclone, S3 command, those can actually be used as part of a scripted backup operation that you could put together. Backup operations where you are doing differential copies of changed content on a continuous basis into the object storage system, and continue to still use your file share or NAS as you need to, because if you have some restriction where you can't migrate apps off of there.
Right. Very true. Okay, let's move on to our last method. And this last method, of course, is typically the most costly, but usually what we found is the one that generates the most success, and that is the professional services method. Basically engaging with people who are used to working with the prior three methods and are able to evaluate, your migration needs and put together a plan for you and the appropriate tool, bring the appropriate tools to bear and then execute on that plan in a timely fashion. And typically professional services are engaged when you're moving away from a proprietary or closed platform, and you need to do that in a hurry. Your time frames are tight, and you don't want to have to learn how to do this yourself. You want to bring in somebody who's dealt with this before. That's their level of expertise. They do this all the time, and they're experienced guides. They can put you on the true path right away to migrate from SAN or NAS or tape to an object store consolidation. Some of the things to bear in mind, of course, are costs, like I mentioned earlier, how much time you have, the length of engagement you can afford to have, and what level of experience you need to bring to bear. Do you need to really bring in expensive big guns? Is it something that you can simply outsource to a team, that's, set up to do more routine work? It all depends on the type of data migration that needs to be done, and it's up to you to determine what level of experience versus cost you're willing to bring in-house to get the work done. Okay, we do have one question. I want to roll back to this question because we've had to push forward. I'll go ahead and read that off. And the question is it true Coringo is an optimal solution to replace a tape library because it is immune to ransomware? And can you send me the name of the next-gen backup solution? Eric, I'm going to let you tackle the first portion of that question.
Sure. So ransomware is really a, it starts with an attack vector, which is something like somebody has opened up an email, it executed something from an email message they shouldn't have, or downloaded some program they shouldn't have, or somehow they introduced into a local desktop, laptop, some program that's going to go through and encrypt or delete, usually encrypt, your local storage. And, in terms of what would the parallel be to that in an object storage system? There really isn't one at this point. I haven't heard of anything that does this kind of thing in object storage. It doesn't mean that there can't be, but there would be some hurdles that would be pretty severe for it. First of all, object storage systems all implement some kind of versioning. You can manage how when and how that's used. But so right from the start, you've got historical copies of stuff. You also don't have this notion of an in-place encryption that can take place like at a block level, like it does with ransomware on your local system. You would have the constraints of network bandwidth. Again, we're typically talking about an attack vector of a laptop or a desktop. It's going to have limited bandwidth to be able to have this wide-reaching effect on the system before it's discovered. So you're going to definitely isolate the impact that it's going to have, and as I said, you have the capability of using versioning as well as remote replications of your content. So having your content in more than one location.
Well, I'd also add to that, Eric, is that typically when you're making these calls, whether as an application or as a client to the object store, those calls usually are authenticated, be it with basic authentication or with token-based authentication. If you set up the storage to be a protected store, it's sitting behind an authentication layer, and that means that any ransomware that comes in has to know how to work with that authentication scheme. It has to have some kind of access to the user pass or token and secret credentials that the targeted individual or application are using to access the object store to perform any kind of thing that it's threatening to do, right? So
right.
If you see something like that and you're working with an object store and it pops up the blurb of, send $10,000 to this anonymous, Bitcoin wallet, or we'll delete all your data. One of the things you can do right away is just simply revoke access, clear out tokens. You can change the password or even disable the account, or even change what that account is allowed to do per policy to the domain bucket tenant that's been assigned to it in the object store.
Yeah, that's right.
Yeah, go ahead.
So privilege promotion is a key factor of viruses and ransomware. They're sort of their initial operations. The first thing they do is they become the privileged user on that desktop or laptop, and that doesn't work. As you said, that doesn't work in an object storage system because you're only privileged to do what your user account is able to do in the object system. You're not able to promote your privileges, to become the super user for the object system because it's not your system. So a vulnerability or the virus or ransomware running on a desktop has no bearing on what you can do. You have not broken into the storage system at that point because they are independent systems.
Yeah, there's no vector there for some executive to have access to, say, a SAN or NAS mount and perform things, independently of that. So once that access control has been removed, there's no way for it to do anything to the object store. And
correct.
And there are other backup mechanisms associated with that. We talked about replication earlier. We have a method in our storage solution with replication where you can tell the replication feed to not propagate deletes. So let's say if for some strange reason there is a way for it to initiate a delete after all is said and done on the local object store, you can still go over to the remote object store and grab the data that you need that it deleted, if it were possible, if you set up the feed to not propagate deletes. So object storage solutions in general provide excellent multiple layers of defense against ransomware attacks, given their characteristics and how they work.
That's right, and I'll actually characterize ransomware as a trend or a fad, if you will. It's a trend or fad because it works. Right now, it works in the context of your laptop or desktop. There's plenty of work going on right now to close that down and prevent it. you know, major operating system releases doing more and more to prevent that necessary privilege promotion that has to take place, or to warn users when privilege promotion is occurring and let them choose not to do it. So, you know, it will pass. It will stop being a thing as soon as the OSs have properly, the operating systems on your laptops and your desktops have appropriately defended against it. There'll be something else after that, but that, you know, it's a trend right now that occurs on laptops and desktops because you can do promotion and you have privilege promotion without detection, and then have very privileged access and fast access to encrypt all the files locally, which just
right.
a lot of that description just doesn't exist in the object storage system.
Mm-hmm. And that ties into the additional considerations that we're showing in the slide here, the authentication and authorization piece. You know, we're talking about off and off that is very fine-grained authentication, authorization, access control lists, you name it, typically associated with object storage access. So,
right.
you know, that's not a major concern. When it comes to migration, another additional consideration, and this is always a big one, and people have to watch out for it, especially if they're moving things to a cloud service provider, and that's bandwidth. You know, that you may not have the bandwidth to move, say, a petabyte of data to Amazon, right? So
that's right. So in encrypting your terabyte, your 500 gig disk drive, you know, you're going to be naturally so constrained to that, and you'll be only able to do what your privilege allows you to do, and you have historical versions to protect you there. So I think we've covered this one and can move along.
I agree. We need to wrap up anyway. We're running out of time. and to that end, we've reached the end of our presentation. Thank you, Eric, and thank you everybody in the audience for joining us today. To keep up with Caringo, follow us on Twitter, LinkedIn, or Facebook. If you have additional questions or would like to schedule a custom demo, please email us at info@caringo.com. And I'd also like to invite you to join us on October 23rd for our next Tech Tuesday webinar, running object storage on a single server. Also, if you happen to be in NAB, New York City, or Supercomputing 18 in Dallas, make sure to visit Caringo at the Expo. Thanks again, everybody, and we hope to see you in our next presentation.